Thank you, and thank you for inviting me here. Before I start talking, I would like to know who is a linguist. So could you raise your hand if you're a linguist? Okay. So I have enough slides to give a talk to linguists and enough slides to give a talk on machine translation. So I'll try to balance it and maybe have enough linguistics to keep it interesting to the linguists. And I hope there's enough machine translation to keep it interesting to the machine translation people. So I'll be talking about joint work. You don't need to read all these names. Some of the work was done at Johns Hopkins University, not in the CLSP summer workshop, but there's a second institute at Johns Hopkins called the Human Language Technology Center of Excellence that also does machine translation and language technologies. And they run a summer workshop called SCALE, Summer Camp in Applied Language Engineering. And so some of the work that I will be talking about was done in the SCALE summer workshop in 2009. And you'll see, you don't have to read all the names, but you'll see some that you probably know, like Chris Kellis-Birch, for example. And his student, Lane Schwartz, mainly built the machine translation system that we used that summer. I also do another project with the Human Language Technology Center of Excellence, which is called Modality, Sentiment, and Confidence Values. And you'll see here that I work with people like Bonnie Dorr, David Urowski, Ed Hovey, Sergey Nirenberg, Owen Rambo, and Mona Diaz. So I'll be reporting on work that was done jointly with a lot of colleagues. And I would also like to mention a new project that's just starting called Linguistic Core Machine Translation. It's a multi-university research initiative. It's funded by the U.S. Army Research Lab. And the thing that I like about this project is that there's two things I like about the project. One is that they told us to be completely crazy about machine translation, to do something different. They told us not to follow the usual machine translation evaluation methods that are used in the United States. They said, do something that nobody's done before. The other thing that I like about the project is the people who are involved. So, for example, we have an all-star cast: Kevin Knight, David Chang, Jason Baldridge, and Regina Barzilay. So this is a very interesting and exciting project. It'll be a 5-year project that just started about a month ago. You don't have to read the references, but these are some of the references of the work that I did with Johns Hopkins, and I'll make the slides available so you can look up the papers. So I'm going to talk about semantics in machine translation, and I'll start with an argument that syntax is not enough. And I think that most of you maybe know that because I've read papers about using a textogrammatical parser in machine translation. And so I have a feeling that most of you know that syntax is not enough for machine translation, but I'll go through the argument anyway. And then I would like to talk about a way to a practical method for incorporating semantics into machine translation that's maybe more practical than the old Interlingua-based approaches. And I'll give an example from the summer workshop in the SCALE summer workshop in the Center of Excellence, where we added modality and named entities to the Joshua machine translation system and got a small improvement in BLEU score. Then if there's time at the end, I'll go into the linguistics of modality and how we actually put the modality into the system. Okay. So I'll start by talking about syntax and semantics in machine translation. This example was provided by Kevin Knight, and he wouldn't say whose machine translation system this was from, I guess to avoid embarrassment. But he pointed it out as an example that after all the years that people have been working on statistical MT for Chinese and English, that this sort of mistake should not persist after all these years. And it's an example of a passive sentence in Chinese. The passive is indicated by this character. And the correct translation should be, my money was stolen by them. But the translation that came out of this system was, I stole the money by them. So in the translation of this system, the semantic roles are not correct. Instead of the money was stolen, no, I stole the money. Oh, instead of they stole the money, I stole the money. So the semantic roles are not correct. This is an easily identifiable pattern that a person could notice, that when you have, the pattern of a possessive noun phrase and the pattern of this they particle and the patient coming before the verb. And yet the pattern isn't learned by a statistical machine translation system, and missing the pattern is not penalized by the automatic scoring metrics. This example is also interesting. Oh, I hope you can read it in the back. I started from an article by Mark Steedman in 2008 in Computational Linguistics, where he was showing that statistical machine translation systems don't adequately handle filler gap constructions, such as relative clauses. And he did a little experiment where he used Google Translate and he put in a sentence in English, translated into Arabic, and then back to English. And the sentences that he used were, the company that bought, this is the company that bought the bank, and this is the company that the bank bought. So both sentences have relative clauses. In the first sentence, the gap in the relative clause is in the subject position. And in the second sentence, the gap in the relative clause is in the object position. And what Steedman found is that regardless of which sentence he put in to Google Translate, when he translated to Arabic and back to English, what came out was the gap in the subject position. So it showed that Google Translate was not modeling long-distance dependencies, not paying attention to where the gap is. So I thought this was curious, and I went to Google Translate and tried a number of different languages. This example is from Japanese. So put in, this is the company that bought the bank with a gap in subject position. And I got out, this is the company that bought the bank. Well, it got to be plural because number isn't marked in Japanese anyway. And then I put in, this is the company that the bank bought, gap in object position. And went to Japanese and back to English. This is the company that bought the bank, gap in subject position. So the same thing that Steedman found. The position of the gap is not modeled. But there's something more curious than that. If you look at the intermediate Japanese, there is a case marker marking whether the bank is the subject or the object. So in this case, the O case marker indicates that the bank is the object. And in this case, the Ga case marker indicates that the bank is the subject. So when we go back to English, we would expect to get, in this case, something where the bank is the object, and in this case, something where the bank is the subject. But in fact, when you translate back to English, you always get the bank as the object. So it's not just that Google Translate is not modeling long-distance dependencies. It's also not modeling case marking and evidence of grammatical relations and semantic roles. This is an example from Swahili. Again, I guess to avoid embarrassment, we don't say whose translation system this is, but it is a current translation system. And in Swahili, the prefixes on the verb indicate agreement with the subject. And in fact, the pronouns don't need to be there. So the prefixes on the verb are, in fact, the pronouns. And so this would be a correct Swahili translation where the subject I is indicated by a prefix on the verb. But this is an output of a current MT system. Some English words came out, and the verb in all these cases is in the citation form, not in the inflected form. So grammatical encoding of subject and object as agreement markers is also not modeled. Okay, so what is the problem? Some readily available knowledge is being ignored. Knowledge about the use of word order, special constructions about the passive, case marking, and verbal agreement markers. This information may sometimes come through by accident, but it's not explicitly modeled in many current machine translation systems. Now, many systems are now using syntax and are able to represent some syntactic structure in machine translation. But syntax alone is not enough. These are not examples from a machine translation system, but they're examples from the language Hmong, which were provided by David Mortensen, a linguist from University of Pittsburgh. And they're examples of different translation of NP of NP in English. So some of the students, a book of mine, a house of bamboo, the top of the tree, the mother of that student, and a bottle of liquor. So these are all examples of all syntactically NP of NP, but all different semantic relations. So a kind of a partitive, a couple of possessives, a book of mine, the mother of that student, material, house of bamboo, another kind of partitive, and a container. And you can see from the Hmong patterns that the patterns are all different, or most of them are different. These two are the same in Hmong. This id is the number 1, which can be used to translate the indefinite article. And in fact, I think the B is not a B, but a tone marker. So I think the word for 1 is B. Now, some of these may translate correctly. Some of these may be distinguishable by the lexical items in current types of machine translation systems. Assuming that the lexical items are close enough to be handled by a language model or to be recognized as a certain type of phrase, some of these might be translated correctly. But if they're translated correctly, it's usually by accident. So what I would like to talk about is how to model this type of semantics in a statistical machine translation system. Another example where we have not been succeeding with syntax alone is in translation of the article the between Chinese and English. And these are some slides produced by a student, Jeff Flanagan, based on Stefan Vogel's Chinese to English machine translation system. The student, Jeff, counted noun phrases, let me back up. He looked at MT output and reference translation and found all the examples where the same noun occurred in the MT output and the reference translation. So if it said teacher and teacher, that matches. If it said teacher and professor, that doesn't match. So he only looked for matches of the same noun. And he found that 36% of the nouns matched. And then where the nouns matched, he looked to see whether the reference translation had the same article, either the, or none. So not counting demonstratives or quantifiers, just counting the basic articles, the, or none. He looked to see whether these matched between the reference translation and the machine translation. So you can see that, so this is 15% of the 36% of the nouns. So this is 15% of all the nouns that match. Had the in both MT and reference. But 8% of the nouns had no article in MT and the in the reference, so MT missed the article. And 10% of the nouns had the in MT and no article in the reference. So MT hallucinated a determiner in those cases. Okay. This is an example of where MT hallucinated a determiner. So in the reference translation, we have 5% of Alzheimer's patients. Patients does not have a determiner. And in fact, it's not referential. It's not referring to specific patients. It's referring to the general semantic kind of patient. In the MT output, we have the 5 patients. So a number of things are missing. Percent is missing and Alzheimer's is missing. But in particular, what's misleading about using the word the here is it takes a non-referential noun phrase and makes it sound as if it's a referential noun phrase, referring to a specific 5 patients. Okay. Now, the reason that I think that this is a semantic problem with determiners, and not just a syntactic problem, can be seen. I hope you can you read any of this in the back? Okay, I'll try to summarize it. It's a table of English and French taken from a typology book by William Croft. And it shows 11 different functions, possible functions of noun phrases, referential types of noun phrases in English and French. Specific indefinite, specific definite, proper name, specific manifestation of an institution, the bank, partitive of a mass noun, I drank wine. In French, I drank some of the wine. Generic mass noun, glory, as in the French love glory, but in French, the French love the glory. And what's important about it is that English and French are both languages that have articles, and they're pretty closely related, or at least they're in close contact. And yet, in only 4 of the 11 referential functions identified, the use of article is the same. So same means they both have the, they both have or they both have no article. And in 7 of the referential functions identified, even French and English have different article usage. So this is what makes me think that article usage is not just a matter of syntax, but is a matter of knowing the referential function of the noun phrase. So, I think the arrows got messed up in this picture. But in looking at translation between English and Chinese, the problem that we're facing is not just that article usage is semantic, but that it is grammaticalized differently in different languages. And so I'm actually hoping that somebody can tell me about the semantics of noun phrase reference in Czech. What we find in Chinese, for example, is that they don't have a grammaticalized notion of definiteness, but they do have a grammaticalized notion of topic comment. And topic comment uses some of the semantic and pragmatic notions that are used by definiteness, but not exactly the same ones that are grammaticalized in definiteness. So we have a problem of translating between languages that have grammaticalized different systems. I'm hoping that somebody will tell me more about Czech later. So we'll skip that one. Okay, so that was my argument and motivation for wanting to do semantics in machine translation. And I'd like to now say a little bit more about semantics in machine translation. This is the machine translation triangle, which is familiar to a lot of people here, I'm sure. And I'm sorry again that the letters are small. I used an example from the Nespole project, which was speech translation, which was roughly contemporaneous with the Verbmobile project here in Europe. And in fact, Nespole was a joint project of the European Commission and the National Science Foundation in the United States. So at the bottom of the triangle, we have direct translation. So if I said in Italian, I'm sorry, I'm not good at pronouncing almost anything other than English. But suppose I said mi chiamo Lori, and then we could translate it word for word. It wouldn't be grammatical, something like mi call Lori. We could translate it as phrase-based. We might recognize that mi chiamo means my name is. And then we could have deeper levels of syntactic and semantic analysis. In the Nespole project, we used the deepest level of semantic analysis, which is that we said that mi chiamo is a way of giving personal information, in this case a name. And so we gave it a very abstract speech act type of representation. Not even in terms of semantic roles, but in terms of the pragmatic function of this sentence is to say your name. So machine translation can be very direct without semantics, or can have different levels of syntax and semantics in it. Now, the pros and cons of using an interlingua for machine translation. Because the interlingua, if you like semantics, the interlingua is really what you aim for. Interlingua is very useful. It can be developed by monolingual development teams. So in the Nespole project, we produced Italian to Korean translation with a team that knew Italian and a team that knew Korean, but nobody was bilingual. The Italian team mapped Italian into Interlingua, and the Korean team mapped Korean into Interlingua. The translations came out good. Nobody had to be bilingual. That was great. Also, some of you who have been in the field longer will remember the arguments for Interlingua in the early days that if you have 7 or 8 languages, instead of having to produce an MT system for every pair of language in every direction, you only need a grammar into the interlingua and a grammar out of the interlingua for each language. So you end up with fewer grammars. The problems with interlingua systems was they were very cumbersome. They required large-scale knowledge engineering, lexicons, comparative linguistics. They were fragile. There was very detailed interaction of rules. The rules could break easily. And they were usually domain-specific. Although we tried hard to make them not domain-specific, we could reuse some things, but usually they were domain-specific. So, and I worked on interlingua translation for quite a while. You don't have to read this now, but from 1980, well, actually from the mid-80s until about 2004. And what you should read between the lines is, I put a lot of time into semantics in machine translation, and I wanted to find a way to make it practical. The interlingua systems were, in fact, not very practical. Limited domain, they worked well in the limited domain, but not very practical on a large scale. Okay. So now I want to move on to give a small example from the 2009 workshop at the Center of Excellence, the summer camp in applied language engineering. And in this workshop, we looked at modality and named entities in machine translation. I'll mention the named entities. I did most of my work on the modality part of the system. So I'll give some results for named entities, but I'll spend most time describing the modality. This is an example of what we mean by modality in English. We have here we're showing triggers and targets and implicitly holders of modalities. So the modalities are things like should and can, and manage, which can mean succeed, and be able, and negation, and believe. These are examples of the modalities. Now, after I talk about machine translation, since I tried to make this talk work for linguists and non-linguists, after I give the machine translation results, I'll go back to talking about the linguistics of modality. Okay, we'll see what happens. So in the phrase should know, should is the trigger of the modality. It's the word that triggers the meaning of obligation. And know is the target of the modality. So the knowing is the thing that somebody is obligated to do. Why is modality important in machine translation? It's important for if you're going to use machine translation in other applications such as knowledge-based population, it's important to know, did something happen, or is it just desired or planned? How likely is it to happen? Who wants it to happen? And so it's related to the notion of activity. We want to know which events happened and which events didn't happen. So if you should go, that doesn't mean that you've gone. If you want to go, doesn't mean that you've gone. But if you certainly went, it means that you've gone. And so some related work that I would like to cite here is Sully and Krzyzewski's work on fact bank, and then also through Johns Hopkins Human Language Technology Center of Excellence. There was some joint work with Mona Diab and Owen Rambo, where they are building a classifier for permitted belief, which is essentially activity. So the work on modality is feeding into a classifier that identifies activity. Another reason that modality is an interesting problem for machine translation is that it's a source of machine translation divergences. So I know this sounds very polite in Japanese. Literally, if you don't go soon, it will be bad. And it sounds very typically Japanese, and it sounds like, oh, isn't it kind of nice that they're so polite? But actually, this is grammaticalized in Japanese. This is not a circumlocution. This is really the standard grammatical way of expressing this modality. So they use their conditional system, which can also be used for if-then statements. They use their conditional system for expressing modality. In Hindi, this is literally you dative, read infinitive, befalls. So it befalls to you to read. It means you should read. This part of the sentence is maybe not so different from English. It's like should read. You can just switch these. But there's also a divergence in that the person who's going to read is in the dative case. So so what's interesting about modality in different languages is that it's usually been adapted to a different part of the syntax of the language. So Hindi is kind of using case marking, Japanese is using its conditional system, and English is using its auxiliary verb system. So you find that usually the translations in different languages are not equivalent syntactically. Okay. This is a kind of a diagram of what we did in the scale workshop. The top of the diagram is training time, and the bottom of the diagram is translation time. So there was funny, this doesn't say anything about parsing. Okay, this was a syntax-based system. The untagged parallel corpus was actually a parsed corpus, at least on the English side. And modality was introduced by grafting modality information into the tree nodes. So this is the main point, that we had an English tagger for modality. This was from Urdu to English. We did not have an Urdu modality tagger. We had hoped that we would, but you know how these 8-week workshops go. You don't always get everything that you wanted in 8 weeks. So we did not have an Urdu modality tagger, only an English modality tagger. We grafted modality tags into the English tree, into the English parse tree. And the modality tags were then projected to Urdu. And then grammar extraction and Joshua training, a syntax-based system, using the Ashish and Andreas' system. It's Venugopal and
SAMT, syntax augmented machine learning.
Say that again. What's Andreas' system?
SAMT did the system, syntax augmented.
Okay, thank you. And then trained Joshua decoder. Then at translation time, we start with an untagged Urdu sentence. In fact, there was not a modality tagger for Urdu, but there was a named entity tagger. We then have a tagged Urdu sentence, and then translation. The modality was projected from the English tags. This is hard to read. Let me see. This one shows English modality tags grafted into the parse tree. So the sentence is, Americans should know that we cannot hand over Dr. Khan to them. And the English modality tagger added that there's a modal verb triggering a requirement modality, and that no is the target of the modality, and that there is a word triggering ability and a word triggering of negation, and then hand over is the target of ability and negation. So the thing that you're not able to do is hand over. And then these node labels were percolated up to the word phrase level. So when rule learning applied in the Joshua system, what was learned was not rules for VP, but for VP not able, VP required. So more specific VP rules were learned. This is also hard to read. This is a screenshot from a report by Chris Callis and Birch, but it shows that the modalities were projected to the Urdu side. The top is English, bottom is Urdu. And you can see the modalities were projected to the Urdu side. I would like to say that after we did this, Kevin Knight pointed out that this was related to his work in a 2010 article in Computational Linguistics called Restructuring, Relabeling, and Realigning for Syntax-Based Machine Translation. And so in that paper, they experimented with node relabeling, using more specific node labels. They experimented with a lot of different kinds of node labels, some of them having to do with subcategorization of the verbs, and some of them having to do with the inflectional properties of the verbs. But they also got a small blue score improvement from that. So the advantage of this approach that we used was that it's good for translation between a less commonly taught language and a common language. So as I mentioned, we did not succeed in getting a modality tagger for Urdu, And so we had to settle for having only a modality tagger for English. And what we found was that you can analyze modality on the more common language, namely English, and project it to the less commonly taught language, the lower resource language. So it's not to say that you can, so I showed slides before showing Japanese and Hindi, and showed that different syntactic structures are used for expressing modality. So it's not that you transfer the syntax, it's that you identify which word is the trigger of the modality, where is the trigger of the modality, where is the target of the modality, and treat those as semantic notions. And that is something that will transfer. The syntax may be different, but the word, so if you say should know, regardless of what syntax is used to say that in the other language, no will be the target. If the sentence means the same thing, no will be the target of the modality. So that is something that transfers. So we were able to do semantic analysis like we used to do in the good old days when we could do Interlingua. We had a lot of fun with modality, and if there's time, I'll tell you how much fun we had with modality. But we also had the robustness of a statistical approach. So we had the semantic depth without this sort of fragile semantic rule system that we used to have in the old days. Okay, so did it work? I should say that Chris Kelsenberg is very proud of this. During the 2009 scale workshop, he got a 6-point increase in Blue score in just a few weeks, so he is very, very proud of that. Only about 0.5 of it was because of the semantics. It was his implementation of the rule learning. It was his implementation and decoding of the rule learning that seemed to account for most of the score. This is going to be hard to read in the back too because it's not very clear. Okay, that's what Chris got for syntax. After he did all this syntax stuff, 26.4, and then this is syntax plus named entities grafted into the tree. So the named entities, instead of just saying noun phrase like Barack Obama, it said named entity Barack Obama. So instead of saying noun phrase, it said noun phrase named entity. And instead of for Washington, D.C., instead of noun phrase, that was also noun phrase location. So grafting the named entity labels into the tree got from 26.4 to 26.6. Grafting the modality information into the tree got an increase to 26.7. And syntax, named entities, and modalities got a final Blue score of 26.9. And here's an endorsement from Chris from the poster that he presented at AMTA last month. Semantically refined grammars help. After syntax, the single best improvement that we had was from semantics. It beat transliteration, minimum base risk decoding, multiple liners, etc. Refined categories better model the distributional properties of nouns and better structure for BPs. There's Chris's endorsement of using semantics in MT. Okay, so can I talk for a little bit longer? Okay. So now I'll go back to linguistics and talk about how we designed the modality tagger that was used in that machine translation system. So I'll say a few things for the linguist now. The linguistic perspective that this is coming from is partly based in construction grammar. Constructions are things that have a form and a function. So, for example, one of Charles Fillmore's recent papers is about the construction, essentially, what's this fly doing in my soup? But more generally, what is X doing Y, which expresses incongruity. what is he doing going to the movies when he has a thesis to write? So it's expressing the incongruity of going to the movies. And constructions can have completely compositional semantics, like determiner noun and noun verb, very compositional semantics, but constructions can also have very idiosyncratic meanings. So there's nothing compositional about the meaning of incongruity coming from this. It's idiosyncratic that this syntactic structure in English happens to evoke the idea of incongruity. So construction grammar is one of the things that we keep in mind, in particular that constructions have form and function. This work is also influenced by language typology and fieldwork. Typology is the classification of human languages. Typologists collect inventories of communicative functions and whether they're expressed or not expressed in different languages. And they have checklists for this. So we've done a lot of work with the Comrie and Smith checklist that's used in the Lingua descriptive series. It's a checklist, if you count it up, it's really thousands of things. But it's a checklist for a field worker going to work on a language and what the field worker should look for in that language. And then, yeah, this is an example of how I'm so sorry for the people in the back that some of the writing is so small. This is just an example of how we've used typology checklists to get to elicit semantic information for machine translation. So we asked, and the translations are into a language spoken in Alaska called Inupiaq. They're translated by Edna McLean, who's a native speaker of Inupiaq and also a linguist. So we would ask things like a man sang, if it's a specific man, sort of the thing like John wants to marry a Norwegian, whether it's a specific Norwegian or any Norwegian. A man sang, specific man, a man sang, not a specific man. The man should sing, the man may sing. So we ask sort of pairs of related sentences. Notice that should and may come out the same. Edna says that this is an optative morpheme in Inupiaq. That's an example of how we use a typology-based checklist to structure data for machine translation. Another aspect of this linguistic framework is the new empiricism in American linguistics, which is a blend of corpus linguistics, functionalism, and oddly enough, a lot of the old generative linguists who were opposed to empiricism have now really started to have fun with corpora. In the 1970s, they used to tell us that rules like dative shift, mother gave him a cookie or mother gave a cookie to him, they used to tell us that this was a stylistic rule, and that both were grammatical and it didn't matter which one you said. But it's probably no surprise to the linguists here that it's not as optional as you would think. It was only American generative linguists who thought that it was optional. So the child was hungry, so mother gave him a cookie sounds better than the child was hungry, so mother gave a cookie to him. The first one is much better in this context. Joan Bresnan, the founder of lexical functional grammar, is now doing these corpus-based studies and modeling the semantic and discourse factors that cause you to choose one construction over the other. She uses a logistic regression model, has about 14 features modeled. So that's the kind of the linguistic background. Oh, okay. I'll try to. Okay, modality is. I'll try to go a little bit faster to go through the how we constructed our modality tagger. The core cases of modality are epistemic, having to do with knowledge, and deontic, having to do with obligation. We used a somewhat broader approach including intention, effort, success, desire. And the reason that we did that is that these semantic notions are often inseparable. So if you say he had to go, the main modality is obligation, but it also has components of, it might have the following components. Maybe someone wanted him to go. At some point, after some coercion, he probably intended to go. He might not have wanted to go, and he was probably able to go. So these sort of semantic components are mixed in with obligation. Desire and intention and ability are often inseparable from knowledge and intention. So that's why we took a broader approach to modality. We skipped a lot of things like evidentiality, which are also related. And we ended up with a simple coding scheme for annotators with require, permit, succeed, not succeed, try, not try, intend, not intend, able, not able, want, firmly believe, and unfirmly believe. And we came up with this inventory as a way to make it easier for untrained human annotators. As usual in an annotation task, we had to simplify for human annotators. So we don't have a not believe because we thought it would be confusing for human annotators to handle the transparency of believe and want to negation. So I don't believe he will go often means the same thing as I believe he will not go. And so to avoid making untrained annotators make that decision, we didn't include a negative for belief. We also didn't include negatives for permit and require, because not require some proposition P to be true means permit P to be false, and not permit P to be true require means require P to be false. So that was so as people didn't have to make that decision, we just didn't have negations for require and permit. We had to deal with entailments and overlap of meanings. So if a holder of a modality manages to do P some proposition, is it success, intent, effort, desire, ability? All of those components are present. So what we did was we tried to order the modalities in order of entailment and have the annotator pick the first one that applied. We only asked them to tag one modality per sentence, and I think that's so. For the 8-week workshop at the Center of Excellence, the modality tagger was a set of T-surgeon rules using this Stanford T-surgeon rule kit, and it included about 15 subcategorization patterns, about 150 lexical items, and so the template would find a modal verb next to another verb and would then rewrite the tree nodes, rewrite the VP nodes as being, instead of just MD and BD, they were rewritten as MD trigger requirement and BD target requirement. So that was done using handwritten T-surgeon rules. There was a modality lexicon that showed the subcategorization patterns of the trigger words, and the subcategorization patterns, these are Longmans Dictionary subcategorization codes, and the Longmans subcategorization codes were what tells us where to find the target of the modality. So large helicopters are needed. The target of the modality, the helicopters, is what's needed. That's in the subject of the passive. The government will need to work continuously. The target of the modality is work, which is in the infinitive clause. Here's transitive need. The target of the modality is the direct object. And then the basic auxiliary without infinitive too, a bare infinitive. So we had subcategorization codes for each modality trigger word in a modality lexicon, and we seeded the lexicon with some 15 basic patterns, and then looked up the other 150 lexical items in Longmans and automatically assigned them to templates based on their Longmans Dictionary subcategorization patterns. That's what this picture says. So the precision was reasonably good on this, on modality tagging using handwritten rules. We had to check it. We didn't have gold standard data, so this was me checking things by hand. And basically checking whether the tagger did what I wanted it to do. And it did what I wanted it to do 86.3% of the time. Depending on the genre, it was up to as low as 82 or as high as 92. But we didn't have a good way of testing recall of the modality tagger because we can't find you can't look for all expressions of modality that aren't tagged because many expressions are special constructions, and I think I have some examples of this. He will not rest unless. So that's a strong expression of desire or intention. That was something that is special construction, not in our lexicon. We didn't have negation on noun phrases, as in no place. And negation on prepositional phrases. So there were many types of things that were not covered. Again, it was an 8-week workshop. We didn't build the ultimate modality tagger. So I think I can basically stop there. The future of this work on semantics is that the modality tags are being integrated into a factivity tagger. Actually, for some reason, we're calling it committed belief instead of factivity. The factivity tagger is being built at Columbia University by Owen Rambo and Mona Diab and one of their students. This is all being done under funding from the Johns Hopkins Center of Excellence. And in the MURI, the Multi-University Research Initiative, Linguistic Core and P project, we're working on other methods for integrating semantic information into syntactic machine translation. So I'll stop there. Thank you.
Thank you very much for your contributions on both the energy and I would like to do several discussions. So,
We're supposed to use a microphone to ask questions.
Thank you. So thanks again for the interesting and inspiring talk, first of all. And I have actually two questions. One is probably easier, and another is more generic and could be harder. So the first one is the projection of the modality text to Urdu. Did you indeed need to project them to Urdu? And if so, how have you handled unseen Urdu test data? Because when Urdu input comes, and you assuming that you have actually trained on a parallel corpus where the modality is tagged on both sides, correctly on it. So my suspicion, without seeing the details, my suspicion is that you don't need to have the Urdu modally tagged at all, and that you actually use the modality tags only on the target side. So it's kind of a language model that handles modality better and makes sure that the output sentence is coherent with respect to modality.
Yeah, okay, so the question is, did we actually have to project the tags onto the Urdu side? And that's a good question. I'm wondering why I have this picture showing the tags projected onto the Urdu side.
And if so, how did you get them on unseen input Urdu data? That's more serious.
We wouldn't. So this would have had to be the training data. So, but the question is why we had to project it on the training data. Because we certainly didn't have the tags on the testing data. But, or
there
would
could
we?
Be,
wait.
There could be a reason, yes, because
No,
Joshua is parsing while translating.
Yeah.
So, and you include the text only in the non-terminals. So,
Right.
by parsing, Joshua is actually adding the information. Joshua itself is the modality tagger for Urdu.
Yeah. Right. So during training, it would have learned the rules with the tags. And then if it was parsing during testing, it may have used the same tags.
Okay, so yeah, so you didn't need an external Urdu tagger at all because Joshua was the tagger itself. That's interesting.
And we were really lucky because we didn't have an Urdu tagger. So it was really good that it worked to just do it on the English side. And then we realized later that, well, why not? I mean, that way we can use the same English tagger for training a lot of other languages that we don't have taggers for. So we realized it wasn't a bad idea anyway.
Yeah. So yeah, thanks. That's interesting.
Okay.
And applicable to other languages and other phenomena as well, not only modality. So it's, and the second question that's probably more generic, and also directly related to the implementation of syntax translation in Joshua. Your claim was that syntax is not enough for translation. My suspicion, and from this department, is yes, I do agree that syntax is not enough, but it's too much in many cases as well. So the key question is, how does Joshua back off? What you are doing is that you are splitting non-terminals. So the verb must is different depending on the modality of given that particular sentence. And if your parallel data does not contain the much in the exact modality manner or way of modality as needed in the input text, then Joshua has to fall back to the generic must. So how this is done?
How does it, I mean, when it...
So Joshua extracts a large grammar, parallel grammar, and what you are doing by adding the modality tags, you are making the data more sparse than they were before, because you are splitting non-terminals. The non-terminals encode some additional information. And I wonder, how does Joshua how does Joshua then solve cases that are split too much, that you don't have enough evidence in your parallel data for?
Yeah, I don't think I can answer that. I think that because I'm not the Joshua person, I think there's some answer to that question in the paper by Wang and Knight and Marku in Computational Linguistics 2010. And oddly enough, they said that it wasn't much of a problem. But okay, you should look at that paper.
Yeah, because this is, and from your linguistic point of view, how would you handle that? That's my problem at this particular department all the time. There are lots of linguists here working and annotating lots of text with lots of features, and we have too many features with too little data to support that type of distinction. So the linguistic analyses are far beyond what the machine can learn and use then.
That's what they always tell me. The most frustrating thing about being the linguist on a machine translation project. They always say we're not ready for that level of detail yet. So yeah, I think it is a problem. I won't be the one to solve it, so I can't really answer the question. Okay. Okay.
Thank you. Well, it's not really a question, just maybe a request. If you could say something more about the new project, this Linguistic Core. You said the agency urged you to be very different from whatever has been done before. So I wonder in what
they told us, they keep reminding us that this is not DARPA. So you know, in the United States, the NIST evaluations and all the DARPA-funded machine translation projects. So this funding agency wants more research on the linguistic issues. And they want us to really do something different that has not been done in the DARPA evaluation. So, that means that they're giving me license to look at things like definiteness and modality. Oh, by the way, I didn't mention that this is the U.S. Army is just opened an African branch or something. They call it the African Command, and so this project will be focusing. Although I think we're not fighting there yet. So they say it's because they're trying to make friends in Africa. They help they train village medical workers and things like that. So their needs are very different from DARPA needs. The DARPA evaluations were designed for the needs of the intelligence agencies. So they need translation into English. They need distinct quality and summarization. But the Army has actual people in 144 countries. And so, yeah, we're interfering in more places than you imagined. And they actually need to talk to people. So this will not be spoken machine translation, but they need translation in both directions. They need good quality translation. They need more types of languages. So we'll be looking at languages that have typological features that are not found in Arabic and Chinese. We're hoping that they'll let us do Malagasy because it's related to all the Austronesian languages. And there are very interesting issues in terms of the voice systems. So in Austronesian languages, you might find that more than half of the sentences are passive or in some other kind of voice. So they're obviously using their voice system in a very different way, related to the information structure, definiteness, animacy. And then the other language we're hoping to do is Kinyarwanda, which is a Bantu language related to Swahili, has a lot of morphology. Each verb has an average of 5 to 7 morphemes, expressing subject and object agreement, tense, modality negation, passive, causative, incorporation of prepositions, applicative verbs. So on this project, we're being encouraged to look at a number of different really different techniques. And then there's going to be some very interesting work, like Regina Barzilay, who's a machine learning person, will look at clustering of concepts by comparing multilingual corpora, not necessarily in the languages that we're going to translate, but by comparing a multilingual corpus and seeing how things cluster, how like context vectors. Shouldn't ask a linguist to talk about things like this. I'll try to say it. So you get some kind of context vectors in each corpus, and then you compare them and try to find the ones that are the same. And so you can discover context across multilingual corpora, and Regina's been doing a lot of work like that. So there's going to be some very interesting work. The center of this will be three transducers that Kevin Knight has used, and also with Jaime Carbonell for a number of years. I've been working on the Avenue machine translation project, which is also a combination of handwritten syntactic rules. So the reason this is called Linguistic Core MT is it'll use linguistic knowledge as seed knowledge. It could be knowledge-specific rules, knowledge of language universals. I think Regina's EMNLP paper recently showed improvements in dependency parsing using universals, like nouns tend to be dependents of verbs. So she used universals as posterior constraints on unsupervised dependency parsing. So yeah, we'll be doing a lot of exciting stuff. It'll be a 5-year project just started.
Some place for stochastic methods in machine learning, like you've said before?
There will be a lot of machine learning.
Okay.
There will be active learning. That Jaime Carbonell really likes active learning. And Vamshi Ambati, his student of Jaime and Stefan, will be working on active learning. Jason Baldridge has also worked on active learning with less commonly taught languages. And let's see. And then Noah Smith and Regina Barzilay aren't so interested in active learning, but they do other kinds of, well, of course, they're both machine learning and kind of adaptive machine learning, not so much active, not so much calling the human in. So the active learning is noticed from Jaime and Jason. The active learning is noticing where the system doesn't have high enough confidence, or and knowing when to ask a human for a piece of data, deciding and then all the experimentation under what circumstances you should ask the human, or what are the most optimal circumstances for asking a human, for the most sparse data, for the most uncertain data, and so on. Yeah, a lot of machine learning. You can see there's a lot of machine learning people there.
Some very superficial. One concerns your table when you compared the use of articles in French and English. And this is just coming from my, I can't say translator's experience because I'm not a translator, but I'm reading papers of my students or colleagues who wrote them in English. And they fear that I should be able to correct their use of articles. And I always say, don't rely on me because I'm not an English native speaker. But in some cases, I ask people who are more reliable than I am, and even native speakers. We had some native speakers with us. And their answer usually was not that they would need to know the context in a more detail, but just saying, well, it can be with an article or without. I mean, that that concerns definite article as well as indefinite article. And so, for instance, in your examples, I think you had something, he showed something, and there you had the, in French you had the indefinite article. And I mean, for me, when I read your examples, I would certainly, if somebody wrote it like this, I would say, well, he showed an extreme care. I don't know whether this is a good example, but it reminded me of my discussions with about the use of articles. So in a way, when you have this table, which, I mean, with the numbers, then I would say that just yes, no answer to article, not article, or definite, indefinite. Well, it shows something, but maybe in some cases it's not that expressive, so to say.
Yeah, there's a few funny things about articles. So that's why we're doing it.
This table.
Yeah. So right. So that's why we're doing this under the project that is letting us go crazy. I mean, we wouldn't try it under another project. So I should say that if we compare, this is the, I forget what year's data this was, but this is Chinese to English, and then there's, because it's a NIST evaluation, there's 4 reference translations. There is some disagreement between the reference translations, but not nearly, there's a few % disagreement among the reference translations. It's hard to tell if it's just because it really is optional. It's also the case that some of the reference translations look wrong to a native speaker. That it was clearly a non-native speaker, and some of the article use is wrong. But the other thing that's funny about articles, and this is why we haven't started working on it yet, because we're still trying to figure out if it really is a problem or not. So let me go back to this table again. People who work on Chinese to English MT say, yeah, it's a problem. There's almost as many wrong does as right does. But the first question is, does it affect comprehension? The second question is, do you really need to change machine translation, or can you just put them back by post-editing the English? And so this study by Na Rehan and other people showed that you could put it back, you could put back the articles, and I think they showed 88% agreement with a human on automatic correction of the articles. So whether or not this is still a problem, no, this was on TOEFL essays. So these were on human written essays. So the question that we're going to look at next is, does this work as well on machine translation output? And I'm sure other people have tried this too, automatic post-editing. There was a 1994 paper by Kevin Knight in AAAI where he showed that English speakers could replace, he had a rule-based system. This was a maximum entropy learner. In 94 AAAI, Kevin had a rule-based system putting articles back in English. So the question is, can it be done on MT output as well as it can be done on non-native speaker English? And does it affect comprehension? Or is it annoying? And if it's 88%, does 88% count as success or not? You know, how do you feel about the other 12%? So there's a lot of strange things about it. So before we really dive into working on this, we're actually first trying to determine how much of a problem it really is.
And my second remark concerns something what we discussed at our lunch today. You gave me a wonderful example, I think, to support the role of prosody, because you had the example, the child was hungry, so mother gave him a cake or or something. And I think you said that in that context, the child was hungry. You can't say he gave a cookie to him. Yeah, you can't unless you put, I think, intonation center on cookie. So I think it might be acceptable if you say the child was hungry, so mother gave a cookie to him.
Oh yeah, that does sound better.
So I think, you know, it's not a matter of, well, for me it's a matter of topic focus articulation.
Yeah,
course,
yeah, it comes out this way in the model, but the Bresnan model didn't include intonation because it was, you know, it's kind of silly that it didn't include intonation because it was switchboard data. So it was originally spoken data. But they were working from the transcripts, and they worked with 14 features, but none of them were intonation.
Okay, so it's a very nice example.
Yeah. Yeah. But they did have 92% accuracy in predicting dative shift even without intonation. And then I did some experiments with ESL learners. We were trying to see if we could get ESL learners to act in agreement with the same feature weights that native speakers acted. And we found that the model was pretty good in predicting difficulty of the example. So if the model gave a score from -1 to 1. So if the score was closer to -1 or 1, it was pretty clear that one alternative was right. And if the score was closer to 0, there would be, even native speakers would have more variation in which one they would choose. It wasn't bad, but it didn't include prosody. But I think you're right about that. If you stress this to make it the new information, because that is what's relevant here, is whether him or the cookie is the older new information.
Well, no further questions or remarks. But I should say that Laurie will be here after this seminar talking to Yiji. Can you wave your hand? About, because Yiji will demonstrate how dependency triggering to you. So if somebody else wants to participate and discuss something, so that's one possibility. And then tomorrow, Laurie will be here at 9:30, discussing and looking at Bara Latka's play, Korev. I mean, the play kind of thing she has. And then at 10:30, she will continue her discussion with Jana about the Olympiad language.
Linguistics Olympiad for high school.
Linguistics Olympiad. So if somebody is interested in that, so you will be most welcome. The meeting points are our secretariat, so both for Bara and for Jana about the Olympiad. So let me thank again to Laurie for her talk and for her company. It was very nice. Share some of your approaches. So thank you.
Yeah, thanks.